preparing to live stream the meeting. You know, they keep changing all these apps, you know, and just drive me crazy because most of the time they're no better than they were, you know. Okay, now this is the normal way it's supposed to look.
Okay.
All right, so we're live now. And I will introduce you. Let me get my camera, my microphone in a better position. All right. Hi, I'm Metta Spencer, and today we're not going very far. We're going to Waterloo, Ontario, which is a nearby in the world. I'm having more technical things than I have ever had before. It says we're live. It says we're live twice, but it's not showing the normal thing. What is going on? Why do they do this? They don't let me know if you're going to do something strange, guys. Listen, audience, be patient. I've got a problem here I'm trying to solve. Whoever you are. Where's the Zoom? Okay. Oh, I know what went on. All right. Okay, I've had that problem. All right. Okay, let's start over. Hi, I'm Metta Spencer. Today we're going to go not very far away. We're going to go to Waterloo, Ontario, which is an hour or so away from where I am now. And we're going to meet a professor who is an expert on water sustainability, Nandita Basu. And she works in two departments, I gather, in civil engineering and in some sustainability program too. So I'm going to get real smart today. I just need all kinds of education about water sustainability and especially some of the challenges of the Great Lakes, which I believe Nandita has made a breakthrough of some kind on. I came across her name in a newspaper or something, and I thought, this is somebody I ought to meet. Because I want to know more about what's wrong with eutrophication in the Great Lakes, if that's what she does. So good morning, Nandita. How are you?
Good morning, Metta. I'm good. How are you?
Great. Okay, let's get acquainted. We have met now a good 3 or 4 minutes ago. And I'm a retired professor too, so I kind of know a little bit about the academic world, but not very much about water sustainability. And tell me what it was that I saw saying that you had, I don't know, received some kind of recognition for some research breakthrough. So tell me about your glory, and then we'll broaden out from there. What did you do that was noteworthy that everybody's celebrating?
So I don't know exactly, Metta, the piece that you read. There's been a couple things that our group has been engaged in or working on in the Great Lakes. I lead a project called Lake Futures, and the idea of this is to think about the Great Lakes and the future of the Great Lakes. So how do we maintain the water quality or improve the water quality in the Great Lakes while keeping on with the economic activities, crop production, and there's also a lot of urbanization that happens there. What are the solutions to these? We do work on wetlands, thinking about wetlands and what they do in terms of improving water quality. So multiple different areas of work, but broadly thinking about our water resources and what threatens our water resources.
You know, before you get down to telling me what I asked you about, I'm already going to sidetrack you with another question that's not quite relevant. I want you to tell me about wetlands, because I am not clear. My original impression, and it's not totally based on nothing, is that wetlands are a source of methane, that things like rice paddies and swamps and things are places where we have the possibility not only of methane, but other things like swamp gas, hydrogen sulfide, and that overall, the wetland is a source of bad things. But everywhere I go now, I'm reading articles saying we've got to save our wetlands because that's our future. Please explain to me what the truth of the matter is.
So that's a really good question, Meta, because I think that's one of the challenges with wetlands, right? So there's different things about them that are all true in different ways, right? And sometimes we get lost in kind of the many different ways. So yes, wetlands can and do emit some methane, but wetlands also sequester carbon because all the vegetation in the wetland, they capture the carbon dioxide from the atmosphere and store the carbon in there, right? So there is a good and a bad, and I think scientists are still grappling with, is the good better than more than the bad, or the bad more than the good? It's not an easy story, right? And that's one of the challenges is, yes, they capture carbon and they build up carbon over the years. And specifically, if you're looking at older wetlands that have been there, they are net sinks of carbon. So there's carbon that comes in and gets stored, and there is also methane, which is also carbon that gets emitted. Like, which is more? How is it more getting more in or getting more out? Depends is a little bit of the answer to that, and people are trying to figure it out. There's studies that show that despite the methane emission, if you, for example, re-wet peatlands, you get a net carbon sink. Also, on the whole, it's better. But this is exactly one of the questions that we are tackling in our new project called Solutionscapes. So thinking about wetlands in these agricultural landscapes and thinking about all the goods and the bads and kind of tallying them up to say, where can we get more of the goods? Because all wetlands are not the same. A wetland in one location might be different. So trying to really understand which wetlands might have a better in that good mode, and then good for what, right? So there's different values that it provides. So that's kind of some of those questions that we are answering, what part of it. But wetlands also take up a lot of the nutrients and store them. Again, because they store these things, they prevent them from going to your lake. So when the nutrients do not go to your lake, your algal blooms are less.
Okay, well, that relieves me because I thought I was dumb, but I'm not totally dumb then. Good, because it's a real question. Oh, amazing.
And it's not an easy answer. It is something that
Okay, thank you for that. But by the way, would you say so they're not all equal? Can you give me a tip about what kinds of factors determine whether it's a good or a bad? For example, I believe some months ago, a year ago, I saw something saying that there's a lot of wetland on the southwest of Hudson Bay, large wetland, and I believe I read that is a major source of methane, that they're getting a lot of methane from that area. But then I couldn't find the reference, and I didn't get any explanation for why it's true. What's the truth of the matter?
So the Hudson Bay one, I don't know, but I will say generally there is whenever wetlands, the methane emission also always should be looked at together with the carbon sequestration, because those are the two pieces of the puzzle. So in that example of that, I would say, what is the net effect, right? So if they are emitting methane, but they are also sequestering carbon, what's the net effect? In a more kind of things that we have done, we do a lot of work on water quality, and we actually wrote this opinion piece a couple of years ago. There was this wetland complex in Ontario that was going to be paved over, and one of the arguments about paving over this wetland complex was that they did some environmental impact assessment on this wetland complex, and they found that, well, there was a lot of contaminated sediment that it was in that, because there's things that have happened. Our area, our lands, our region is very developed, so there's contamination in there. And their argument was that it's not the best wetland. Your wetland in the Algonquin parks or in those natural wetlands are better, right? And so it's okay to destroy maybe this one for something, and then we'll build something over there or reconstruct. And the opinion piece we wrote with another colleague of mine, Rebecca Rooney, who's a biologist, is primarily the main idea being that a wetland that is near your agricultural area or your urban area is capturing those pollutants that you need to be captured before the water goes to your shore. A wetland in the Algonquin Park has other benefits, but it won't capture those pollutants because they are not there. It's forests around there, right? So wetlands in different areas provide different function. And wetlands in our very developed Southern Ontario are kind of like the water filter in your home. They clean your water before it goes to the lake. And all these beach fouling or these regular things, we have beach closures, so they lessen that. And that's
if they paved over this wetland, would it, I presume it would keep it from ever functioning in that way again as a filter, right?
exactly.
Okay. Yeah. Now I have heard the most remarks that I've heard saying we have to save our wetlands have to do with the notion of reversing the fact that so much wetland has been drained, and that that is always bad. Is that always the case or not?
Always the case. We have drained so much of our wetlands, and the wetlands are kind of this unique ecosystems. They provide so many functions, like they protect against flooding, they improve the quality of our water, they sequester carbon, biodiversity, they are extreme biodiversity hotspots. So there's just so much value to wetlands, but also wetland soil is very fertile, right? Because there's a lot of carbon in that soil. And so this is the reason we have drained wetlands, because when you drain that wetlands, that's prime agricultural land if you can drain it well, right? And so we put these drains that are called tile drains under these wetlands because water puddles there, and we want to take the water away because we want to grow crops. So they have been drained over in our regions. I would say we've drained at least 70 to 80% of our wetlands.
Okay, and that makes them not a sink anymore, right?
Yes, exactly.
And also, I have a lot of contacts with Russia, and I remember about 3 or 4 years ago, they had huge fires that were underground. The peat from hundreds of miles apparently caught fire, and apparently it's almost impossible to put out. So even there was smoke. I don't know how the smoke got out, but there you go. My friends were having to move out of their apartments and homes because of the smoke. Is that I presume that means that the main advice we can say is don't ever do that, don't drain it. And can you restore land that has had that done to it, drained?
So the short answer to that is no. When you restore a wetland, for you to get back to the natural wetland, it will take many, many years. But that doesn't mean you should not restore wetlands. You should restore wetlands because they do, even when they are not fully functional as they were in their original state, still they are very useful. So we are studying a set of these 8 wetlands in Southern Ontario with Ducks Canada. And one of the things that we are seeing is, and these are all small wetlands in farms, right? So farm ponds more, and they are so effective at catching nitrogen and phosphorus in them. So, and these are restored wetland in these farm fields.
Okay, so it can be done, but it takes time. Okay. Thank you. I've diverted you now from telling me about your wonderful accomplishments. So thank you for the side trip, but nevertheless, let's get back to work.
No, but wetlands is a big. So wetlands is one of my the ideas of wetland conservation and protection and restoration is one of the key pillars of our work. One of the things we are doing is asking this question specifically, right? Which wetlands to restore and what kinds of benefits that we will get by restoring them. And also being very honest about it, what kind of negative things might happen, to really understand what are the pros and the cons, and try to understand that, like for a wetland here versus a wetland in the Algonquin versus, so different kinds of wetlands can provide different kinds of functions or values. And it's important for us to understand that.
Can you do anything experimentally? In other words, could you take a piece of land and wet it and just measure the methane emissions and see whether it was, and also how much carbon it's sequestering, and just get a ratio of one to the other?
Yes, and there's people in Canada and all over the world that have done and are still continuing to do that. There's a huge amount of wetland restoration, and that's ongoing. The study we are doing in Ontario is that where there's a bunch of wetlands that have been restored, and my colleague Tanya D'Alessandro is studying methane emissions from those wetlands versus natural wetlands. What our group does is a lot of kind of data assimilation. Because there's so much experimental data that's available, we do what we called meta-analysis, which is gather everybody's data from all over the world from many years, and then kind of put all that data in a big pot together and say, can we see some of the things coming out of it? Because when you study one wetland in one place, you could say, well, your wetland is different from my wetland because there's just so much heterogeneity. So as you get more and more data in this pot together, you can get more and more confident.
Okay, that sounds good. But that depends on your being able to measure everything that you would need to measure. I'm not sure whether, can you tell me how much you can expect to do by way of measuring methane emissions and measuring carbon sequestration?
So there's many methodologies people have been working on, not my area of expertise, but generally there's methane. When methane is emitted, it can be kind of diffusing out through the water. It can go through the plants. So there's many ways of measuring it, and people have been perfecting those ways. They put these funnels in the water and kind of get the gases, trap the gases in the funnel. So there's many methods and many instruments to do that. So yes, you can. Of course, these methods keep getting better and better, and no end to improvement, but we have ways of estimating how much methane is emitted. And also the way people do carbon sequestration is they would take these soil columns from the wetland, and then you would date the soil columns, figuring out what part of the soil came, what's the age of that soil, and figure out carbon sequestration.
Okay, well, I'm glad there's progress. It sounds hopeful. Thank you. Now, get back to telling me about your glories. What have you done that I should remember from having read, but don't?
So as I said, so broadly our goal is to think about water quality in Lake Erie. A part of our work focuses on thinking about this question of legacy nutrients. So the idea is that we've been applying nitrogen and phosphorus to our soil from the 1970s, 1960s, right? It's been a long time. And some of the phosphorus gets stored in the soil, so that even if you reduce applying phosphorus, that can bleed out. So we're trying to figure out how much, where it's stored in the landscape, and how can you use that effectively. So we map out, we look at agricultural data, kind of map out what the phosphorus inputs and outputs are, where the hotspots are, and how much potential legacy phosphorus can be in our sediment in our soils. The plus of this is if there's legacy in our soils, then you can apply less fertilizer and get the same crop out of it, but you can protect your water. So that's one kind of area of our work that we are looking at.
Okay, that sounds a little familiar to me, because I've already had conversations with people about the dangers of chemical fertilizers or synthetic fertilizers, and I believe most of the problem does come from fertilizer, doesn't it?
Yes, fertilizer. Well, so Fertilizer, as in chemical fertilizer, but also livestock manure is a big part of that equation too.
Mm.
So it's both chemical fertilizer and livestock manure that is responsible for the extra nitrogen and phosphorus we see in our water.
Okay, now you've mentioned something that kind of threw me off balance, because I've been thinking of, I have only heard of manure, animal manure, as something highly desirable as a way of adding fertility to the soil. But now you've thrown it in together with this bad stuff that's a pollutant. When is it a good thing and when is it pollutant?
So it's again the same idea, right? That something can be both good and bad depending upon where and when. So you're absolutely right. Manure adds nutrients to the soil, adds carbon to the soil. And traditionally, when people had small farms and small livestock operations, that's what they would use on their crops. They would use the manure on their crops. But what happens with livestock manure a lot of times is that they are produced a lot in some locations. And it's when you apply it, you need to apply it over a much larger area. So you're not applying too much. Too much as nothing is good. It's the same thing about our food. Like we need food, but if we eat too much, we get sick. Similarly, manure is a good thing. It's needed for the crops. It's the nutrients. But a lot of times, because manure is also not easy to transport to farther places, if you're producing it at one location, you might apply it near that area and you might apply too much. So if you
So
drive
a feedlot, for example, would be a place where you'd get too much in one place. Is that it?
Exactly. So a lot of times you can smell it when it's applied, and a lot of times it's applied. Sometimes it's also applied on top of snow, which is a really bad thing to do, because then your crops are not there to take it up, so it just runs off into your water.
Mm-hmm. Okay, now again, you're triggering an association of mine, which I hadn't expected to explore with you, but let's do it. And that is, I'm going to be publishing in the next issue of magazine a transcript of a conversation I had 2 years ago with a professor at the University of California in Davis, who specializes in the emissions of enteric emissions from cattle. And he is very much in favor of the meat industry, of ranching and so on, and defends it against, well, I can loosely say against the vegan world. And so I thought it was extremely interesting and of course, very controversial. I expect all my friends are going to hate me because my friends are becoming vegans. But at any rate, the argument there is, and he was not particularly the one promoting this argument. In fact, he says he's not an advocate of this holistic management approach of Alan Savory and his followers. But I tend to be very impressed by Alan Savory's work and the people who are using his ideas. And the idea there is that you want just the right amount of manure and urine and other things to be applied to the soil, and sort of the soil should be roughed up a little bit. So if you keep herds of animals in big clusters and move them from one paddock to another at just the right time, they will have stirred up the soil, eaten the grass, and left their poop and stuff in just the right amount so that they enrich the soil and make it fertile again. So I've seen dozens or hundreds of photos of land that has been restored from desertification by this method of herding animals. And instead of allowing them to scatter freely over large pasture, you keep them bunched together and move them at specific times when they've done just the right amount of work on the soil. And that it does involve adding the nutrients from the manure and kind of stirring it into the top of the soil. tell me what your impression is of this theory, because I'm going to call it a theory and not a, well, it is an approach, let's say. And does that have any bearing on what we've just been talking about in terms of the predominance of the polluting quality of manure as opposed to being a benevolent thing for the soil?
So I'm not an expert on dairy systems, but I would broadly say my understanding based on peer-reviewed literature is that at the rate of meat consumption that we have, the density and that we need, and the consumption of water and other nutrients that cattle production needs, there is inherent unsustainability with it, and some of these viewpoints about it could be done sustainability, I've not seen peer-reviewed numbers that really speak to that well. So that's kind of broadly. There's multiple ways people talk about doing it. There's some that are better than the others, but part of it is kind of like, this is more personal. It's, to me, it's not about these extreme viewpoints about let's all go vegan versus everything is okay with. It's more about recognizing meat consumption, thinking about it in a holistic way, thinking about maybe reducing it, but not going completely. So there's just these multiple layers of that conversation. But livestock production takes up a huge amount of, just to feed the livestock, right? If you forget everything else, just to feed the livestock, there's huge amounts of 10 times more or 100 times more pasture crops that you need. And to grow that, you would need nutrients to be added to the soil. So there's many layers to that argument.
Okay, that's very informative. Because I want to hear all sides, and it certainly is controversial. Okay, again, I've steered you away from your preferred area. You want to talk about the Great Lakes.
Well, yes, one of the things is this livestock piece. So one of the things that we realized with our work is we always definitely blame chemical fertilizers, and I think chemical fertilizers is definitely a big piece of the puzzle, but livestock manure is also an important part of that puzzle, and proper manure management. So some of the models we developed basically says that if we focused our attention on proper manure management, we could address some of these issues much better. And so this is kind of led to another project that we have, which is asking the question, if you added biodigesters to the landscape, so where you take the manure and convert it into energy and figure out ways for effective taking the digestate and applying it to soils in amounts that you need, might be a economically viable option. So we have this project that's evaluating how feasible it is at the landscape scale, what are the costs and benefits and things like that.
Okay, when you say biodigesters, totally new word for me. What's that about?
So these are a plant. These are where basically you take manure, you might take food waste, and you have bacteria digest this material, break up this material, like in a wastewater treatment plant, right? So they're breaking it up, and you actually can generate methane out of it. You can capture that methane and convert it into energy. So there's local like larger scale dairy farms sometimes have these anaerobic digesters on their farm, where you can actually use that and get energy out of it. And so you can have electricity for your region with that. And then you also produce digestate, which is kind of the solid material that comes out of your digester. And then that digestate also has nutrients in it. So then you have to figure out where you apply the nutrients, but sometimes those might be easier to transport over larger distances, so you can apply it to the landscape.
Mm.
It's
okay,
a way.
this fellow that I talked to 2 years ago was talking about, he lives in California, so he says it's a big business now. They have lagoons, he calls them lagoons, where they put the animal waste, and then nowadays they put plastic or something kind of tarps over the top of the lagoon to keep the methane from escaping, and then they capture it and can use it. And I think then I don't know whether he didn't say anything about biodigesters, but I think he was assuming that it does on its own produce methane, and then the residue can be used as fertilizer.
So that is one of the kind of lower end, but there's much more also technologies available that to fasten up the process so it becomes economically efficient at a larger scale. And there's
what would they put into the waste material to?
So bacterial and various chemicals. Again, the functioning of the digester is not something that I have expertise in, but it's similar to your wastewater treatment plant. Right, in a wastewater treatment plant, when you get wastewater and solids, you put them through these digesters, biological digester systems with that breakdown. So in a natural system, there is bacteria that would break it up, but you want to speed up that process so you get more energy out of it for the time you're investing in it. So, and there's multiple technologies, and technologies are getting better and better. There's also Canadian Biogas Association. So there's companies that build these digesters, and there is and also like this is not just about livestock waste, it's also about municipal waste. So there's
it's like a tank, and they put chemicals in the tank along with the waste.
Exactly.
Okay, now are there people actually doing this now, or is this kind of a dream?
No.
Thing.
It does exist. So it exists at farm scale. Yesterday, a colleague of mine was telling me about one farm in Elmira that has it. It's done in municipalities. I have a colleague in who is doing a lot of these anaerobic biodigesters for municipal waste. The technology exists. There's a group of people in Waterloo and elsewhere that are doing research on how to make this technology more and more efficient. The technology exists, but it's still not done on a large enough scale because there is this cost benefit aspect to it. If you are a large enough farm, you can afford it. If you are a smaller operation, you can't really afford it. The project that we are doing is kind of asking this question: if there were truckers that trucked them to a centralized location, how many would it be cost effective? Like, how many would you need across Ontario? Where would they located? And what are the costs and benefits of those kinds of processes?
Now, this cannot be really completely new idea, because I was in China as a visitor in 1980, and I think it was, they probably showed us around to their showcase farms and not typical farms. So I doubt that this was widespread, but we visited a family in their farm that had a system whereby they collected their human and animal waste and got it and collected the effluent. I mean, not the effluent, but I suppose the gas. It must have been methane, but I don't think they told me what the chemical, what the gas was. But they used the gas as a fuel or as a lighting system. I think they had like kerosene lamps or something equivalent that they used for their lighting, and used the products of their farm that way. So that was 1980. I'm sure that what you're talking about is vastly more sophisticated, but this was certainly a primitive precursor, I would assume.
Yeah, and the technology is not new. The technology has been there and it's improving. What our work is focusing on is asking, it's still not used in a widespread way, and that's because about the cost and benefit of the process. It's not economically. So if you do the math, you will see you have to have this many cows for it to be economically feasible for you to undertake the capital cost of this technology. Right? So only larger operations have it. What our project is looking at is, if you wanted smaller operations to have, smaller farms to also use their manure that way, you need somewhat of a centralized system where many farms would pool into this resource. And then you would have to think about, like, if you want to truck your manure to a centralized facility, what are the costs of that? Who is doing it? So that's kind of what we're trying to do. And where do you want these facilities to be there? So that's kind of figuring out how it can be made cost effective at a large scale. The technology does exist.
Okay. Well, now let's talk about the Great Lakes. And well, I suppose I want to ask you about eutrophication, but also other algae. I believe your work involves something about how to manage algae in the Great Lakes. Tell me about it.
So in essence, the idea is that we put fertilizers on our crops, and fertilizers have nitrogen and phosphorus. And phosphorus has been shown that it is what is causing these excess algal blooms, and sometimes these algal blooms can also be toxic. So they emit these toxins. And so what our work focuses on is understanding how to reduce that phosphorus application while having the same kinds of crops that you want, what aspects of the landscape are important when you're thinking about phosphorus, how to manage. So this is why, like, one of the solutions in this is put wetlands. And then we say, well, where do you want to put this wetlands? Where, if you want to maximize your phosphorus removal, right? Which locations? Another solution is, well, you do not put so much extra manure on the land. Well, what do you do with it? You can't just tell the farmer, don't put it. They have to do something with it. So this is where the biodigesters, can we make a cost-effective way of thinking about these digesters across the landscape that will reduce the extra phosphorus that you're putting in? That will mean that there's extra phosphorus that goes to your lake and causes these algal blooms.
Mm-hmm. Okay, so you're not out there in the water so much as you're on land trying to take care of the things that are going to get into the water before it gets there. Okay.
Exactly.
Yeah. Okay, that is
and so in the broader project of Lake Futures, not my work, there's others that work on the lake, right? So so our subgroup works on the land that drains into the lake, and there's also a subgroup that works on more the lake processes, and also thinking about lake sediment. So there's legacy phosphorus in lake sediment and what that means in terms of water quality.
Oh, all right. Well, tell me a little bit about that, because I hadn't thought about that. So if there's legacy phosphorus or nitrogen in the lake, it's at the bottom, and does it do any harm, or is it?
So it can potentially release into your water column and provide phosphorus. And that's the part that we're trying to figure out, how much comes from the sediment released to the water column, because when you have sediments that is released from the sediment to the water column, that's called internal loading. That phosphorus can also be used by algae to grow.
Mm-hmm.
Right? So we're trying to figure out how much of it comes from today's land, how much of it comes from phosphorus that you applied 10 years ago versus how much of it is in the sediment sitting in there. So really trying to understand the different pieces to say where, if you go and make a change, you will see improvement.
Now, I believe that not all the Great Lakes are equal in the extent of their pollution or their eutrophication. And you mentioned Lake Erie. Is Lake Erie the most advanced in its deterioration?
Yes.
And why?
Well, it's shallow. One of the reasons it is so much of a problem. So when a lake is shallow, then it heats up in a different way. So when you add pollutants to a shallow lake, there's not as much buffer to absorb the pollution. So that's why you get more algal blooms in the lake, versus the same pollution in a lake like Lake Michigan, which is deeper, might not give rise to as severe problems as you see in Lake Erie.
Mm-hmm. But so what is the actual, problem with Lake Erie? Who's being adversely affected by the state of the water? And is anything being done to try to clean it? Not your end of it, where you're going to prevent its happening, but clean it up now that it has happened. What is being done that way?
So multiple different things. The first saying first question about who's being adversely affected, multiple. What happens in the process of eutrophication is every year you get the phosphorus from the land that comes to the lake in spring runoff, when you have your snowmelt runoff, and that fuels this blooms of algae that grow. Sometimes you get toxic blooms, and there was this one case where Toledo, the drinking water treatment plant in Toledo, had to be shut down a few years ago when there was this huge toxic bloom that happened. Also, when you have a toxic bloom, of course, you take your dog to the beach, and there's incidences in different regions where they've gotten sick.
They've been poisoned. The dog is.
Yeah. So toxic.
Are they more susceptible than people?
Yes, and also they are in the water more than people. Like a lot of times there's warnings, but then dogs will still go in. So there's when you have toxic blooms, that's a big challenge. And the one thing I would also like to reiterate, we think a lot about the Great Lakes. What we also really are encountering, which we should talk more about, is all the other smaller lakes that are in Ontario. It's not just the Great Lakes. So my project manager, Laura, she was talking about some blooms being spotted in the lake on which her cottage is. And she's disappointed that she can't go swimming because some blooms have been spotted, right? Because whenever there are blooms that are spotted and these blooms were blue-green algae, which have the potential to be toxic blooms, you don't want to go swimming in that lake.
No. Can you see it? If you're walking along the edge of the lake, can you tell there's a spot of it?
So you can say that there are algal blooms in the lake. There are some kinds of algae, those are the blue-green algae, you might be able to see, but whether they're toxin producing or not, that's not as easy to detect that way. There's multiple tests to figure out. But blue-green algae, you can see. And then also there are these things where you can find reports on, there's Algae Watch and a lot of other organizations that work on detecting and providing information to public, so don't go there. But that's one of the.
I've seen lakes that have green scum on it, slime. Now, obviously, I'm not going to go into that lake, but in fact, I think I'm thinking I used to teach at the University of Toronto in Mississauga, and there's a pond there. I haven't been out there in ages, but they did have this slime on it. But the ducks and the geese, nevertheless, were there. Is it okay for ducks and geese, or do they ever get poisoned or by it?
So all of the green scum is not necessarily toxic algae, right? So there's a ton of just algal blooms that you would see, and those algal blooms have their own problems. So even if you don't think about toxic blooms, regular algal blooms, what happens is that there's a lot of plant matter, right? So these algae then sink when they die to the bottom of the water. Bacteria degrade it, consume oxygen, and turn the water to be low in oxygen content. And when that happens, you have fish kills and things like that. So that's kind of one of the impacts of algae, whether they are toxin producing or not.
Okay, so it kills the fish, and I guess it also kills the ducks and everything else, right?
But they would probably, I mean, things that can move away a lot of times will move away. I think a lot of times when you have those times, they won't stay in those regions. But algal blooms that you go around, it's everywhere. Like every pond that you go in summer has an algal bloom around these regions, right? It's tough to find ones that don't.
Really? Okay. What I wonder is if it happens one year, can you be sure that it's going to keep going the next year and so on? Or do you sometimes have an outbreak and then clean for years?
So it's not necessary. So it depends on which lakes you would be talking about. So a lot of times when you're thinking about these lakes that are more in forested areas or not so much agriculture, lakes that you have cottages by. In those lakes, blooms have been increasing, which means that you're not necessarily seeing it every year, but the frequency of you seeing it is increasing. So, and it varies from year to year because it depends on when your rains happened, when the temperatures increase, the specific kind of climate thing. So it varies from year to year.
And the winter time, it's going to die. That the stuff is gone, right?
yes. But then
Okay.
it comes.
But it'll come back. Okay. Okay. Well, so this is affecting cottagers. Is that right? That they are concerned about? They don't want to go in the water. Can they? How do you tell? I've heard. I can't remember the name of it, but there's one particular kind of algae that I think is supposed to be really, really bad, really dangerous. Does it start with a C?
Cyanobacteria, cyanobloom.
Okay. The cyano sort of implies that it contains cyanide. Is that true?
So I don't know so much about the toxin content, honestly, so to be able to speak to you, but those are cyanotoxins are what these algal blooms are, and those are the toxic blooms. And they are coming up, they come up in sometimes in our reservoirs, and then there are warnings that our drinking water treatment plants have. So when they detect that, then they would have to figure out ways to treat them or get other sources of water till that goes away. So it is a very real continuous problem that is increasing in our waters.
Okay. But now some of these cottagers, I assume, use buckets of water from the lake and might not know what's in it. Yeah.
So, I mean, I think a lot of the cottagers that I have talked to, they, at least for their drinking water, always do bottled water. And I always recommend always do bottled water because even when you're not seeing anything visually, there's a ton of stuff in these waters that are not treated. You do not want to drink them. So if you're using them for other purposes, maybe that's okay as long as there's no cyanotoxins in it, but definitely not for drinking.
Now, one of the things that I've heard of also is hydrogen sulfide. I think it's called swamp gas. When does that occur? And is that, I remember reading about a year ago about a couple and their dog and maybe a child were out walking in, I think it was in California, and they were all found dead, and nobody knew what, went wrong. They just all dropped dead, apparently. And apparently, the best they can figure is that there was hydrogen sulfide emitted from something in the vicinity. Tell me about that. If you don't have anything to worry about, let's start worrying about hydrogen sulfide.
Well, there are many reasons why that can happen, right? And it's tough to, I mean, there's natural sources of hydrogen sulfide gas from very reducing conditions. So whenever a condition, if there is sulfur in a system and it goes in this condition that's very reducing condition, low oxygen condition, you might see emissions of hydrogen sulfide gas. The case in California you mentioned, I remember that. I don't know whether they came to any conclusion on what exactly happened in that scenario. But broadly, I would say there's incidence of these blooms and these toxins in areas that we normally think are more pristine and wouldn't think twice about going in a river and drinking water in some areas. And I think the fact that we are seeing more incidences of blooms in these areas is something that we should take seriously.
Okay, so you are doing the research. Tell me how you're researching it. Tell me, how you spend your days, so to speak. What is it you are looking at, and what's your, methodology?
So I am a data scientist and a modeler by training. So what I do is I work a lot with available data sets that others have collected. This includes the province that is collecting water quality data, other researchers that have collected data, and we use a lot of artificial intelligence and machine learning kinds of approaches to try to understand the data, right? So to try to make sense of the data, because data can be very messy, and to try to develop models to say, well, if you do this, what will happen? Right. So if you
give me an example of what of some output of your most recent paper. Tell me about your most recent paper.
So let me give you one example, since we were talking about wetlands. One of our papers that came out in Nature, in the journal Nature, a few years ago. The main idea of that paper was to ask the question, if you lose wetlands, what will happen? And if you restore wetlands, what will happen, right? And in this case, we were asking the question in the Gulf of Mexico, Mississippi River Basin. And we asked the question, if you restore wetlands, if you take away all the wetlands that exists in the Mississippi River Basin, what will happen? And what we found was that if you did that, your pollutant load would double. Oh no, would go 4 times to the Gulf, which is a large number.
Oh, no.
And then we said, well, if you want to restore wetlands, how much wetlands do you need to restore to improve water?
Okay, now that's interesting, because of course I've visited Louisiana, and I never thought about the notion that you're saying that the quality of the Mississippi River and the pollutants that's going to dump in the Gulf of Mexico is affected by the wetlands on the shore.
Not on the shore, wetlands everywhere within the basin, every farm field. Right, so it's not just those wetlands on the shore, it's wetlands.
How does the water from the river get into all of this wetland?
So it's the other way around, right? So if you think about a river system, there are farm fields that drain, that have water from, but that rains on the farm fields, that drains into the Mississippi River, and then the Mississippi River goes into the Gulf. So it's all connected. There's 3 million square kilometer, that is all of the water from that 3 million square kilometer goes to the Gulf. So when you put a wetland that traps your nitrogen or phosphorus before it enters the Mississippi River, you're improving the quality of water in the Mississippi River, and that water that goes to the Gulf, you get less pollutants in there.
Oh, okay. Well, I would have assumed that most of the river water had flown 1,000 miles from, the upper states in the U.S. and had picked up all of the pollutants there, and that maybe too late by the time it gets to I guess they call it a delta.
That is what I'm saying. That is what I'm saying, though, Meta. So they do pick up all the pollutants there, but that's where you restore the wetlands. You restore the wetlands not in one location in Louisiana. We were talking about restoring in the upper areas over the entire base. Kind of making the point, if you want to solve this problem, you won't have to solve all of it. You just can't go solve it at where you're seeing the problem.
Okay, that makes sense to me. Oh gosh, that would be very ambitious. I mean, for one thing, I can't imagine the US government buying it. I mean, imagine what it would take. You'd need to buy up everybody's farm, and no.
No, and that's the thing about this paper. It's not, you don't need to do that. And this is true about Lake Erie, all you need to do is every farmer saying, I have this plot of land, and a lot of times these are big plots of land that you have for agriculture, and there's this low-lying spot in my land which doesn't give the best crops anyway. I will convert that spot to a wetland. And if every person says that they will do that, it's like little things, and they will add up to really clean your waters. The same idea in the Lake Erie Basin. You're not talking about taking away people's farmland and converting them to wetland. You're just saying if every person has one wetland or two wetlands that is within their farmland while they are growing crops around it, which some people are doing, then they are cleaning their own water. It's their own private water treatment filter before it goes. And so the water will be cleaner.
Okay, so you just are doing a little public relations or persuasion from not, could you have legislation, or do they consider it in terms of, say, every farm has to do this or that because this is an emergency?
Legislation is always challenging, right? But there are also ways to get funds, both in US and Canada, towards it. And one of the things we showed is if you did do your most ambitious goal of restoring that many wetlands, the amount of money that you would spend is actually not different than the amount of money that is already spent on a lot of these kinds of things. So what our project or finding is that if you took that money and focused it in ways where you do it where it's most efficient, you can actually address the problem better.
All right. So did you say this was published in Nature? That's a prestigious journal. Did it have some political impact? Did anybody get in touch with you and say,
so I think the path from when you publish to when it starts getting an impact is a long and circuitous path. What did happen with that paper is that DU Canada, Ducks Canada came in, and DU International, which includes US, came to us and said, hey, we got some money to restore wetlands. Which wetlands do you think is the best to restore? And so we now have a project in the Lake Erie Basin asking that question, right? So it's not that, and honestly, in the world of wetland restoration, there is money that's coming in from like a climate perspective on wetland restoration, both in US and Canada. And where we would like to see our work go is the effective use of this money to restore those wetlands that will have the most effect.
Mm-hmm. Sounds like one of the elements of it is simply getting the word out, because I mean, I'm trying to think of how many people are going to watch this show and how many of them are going to be farmers with wetland. Probably not many. Question is how we could get this kind of information out to those people, because they're the ones who might need to be informed about it.
Exactly. And one of the farmers that I was talking to who has the set of wetlands, he talks about it so beautifully, about the legacy of this land that he's leaving. He says, I love my farmland and the farming that I do, but I actually really prize this wetland that I've built over here, because that's what I leave to my grandkids, that space. And he has this beautiful kind of sitting area beside it. It gave me goosebumps to just talk to him, how proud he was.
That's wonderful. Okay. Now, you mentioned a while ago that what you do is a meta-analysis. You collect data from all over the world, as much as you can get, and put it in one big pot and do the analysis on that huge data set. Where do you get your data, and is it difficult? And I think that is an interesting challenge. How does that work?
So it is difficult and time consuming. So the way we would do it is we would first collect hundreds of papers, and then we would go in and see what is the information that they have provided in those papers. Sometimes those might be in forms of graphs, and then we will have to digitize them to figure out that information. So it is really backbreaking in terms of that. But our group has this philosophy is that there's a ton of work that is done, and we really want to learn to build on that work and so that's kind of a big part of what we do. But it is a lot of work to do it.
Well, do a lot of other countries collect a lot of data, or is it's really almost all, say, North America and Europe, and then you just here and there get a little piece of information elsewhere?
That is also a really interesting question, Meta. I'll tell you why. So when we did the wetland work, we did that. And one of the things we found is that most of the wetland data that we got was from North America and Europe. And then I had a student from China reach out to me and want to work with me. And I said, what about data in China? Because you have a lot of funding that focuses on environmental pollution. Do you collect data? And so he now has a paper with us that has done a similar work using papers that are written in Chinese language. And turns out there's a huge amount of data in China. We didn't see it as a global community. And he's now published this paper with all of these data points from China.
And so he's able to get access to it. Would you be able to get access to it for your own purposes?
So the access in this case, so a lot of this data is not government data, it is researchers' data. So it sits in publications. So the way you get access to it is kind of go through the papers and get that data from that. And these papers are open access. But the work in kind of getting all of that is a lot of work. And for me, I would not be able to do that because I would not be able to read those Chinese language papers and be able to get that data, which he was able to. And now it's in an English language journal and it's accessible and usable for others to see and be able to use.
Have you thought of, and I wonder whether it's possible to use AI, chatbot and stuff to translate. I just did a little translation. I wrote a letter to people in all Latin American countries, short letter, and I had GPT-4 translated into Spanish. I have no idea what it wound up telling them. Probably, who knows what it was actually said, but it did translate it, and nobody has written me in shock saying, "What do you mean by this silly
Well,
combination?"
Of course, I mean, ChatGPT can do a lot of translation, but when you're thinking about doing this for hundreds of papers,
Yeah.
it's trivial. And also more importantly, I think it's important when you're working with these data sets to have people from that country because they know and live and understand that data in a way that no ChatGPT or AI could do, right? So to me, part of it is also this student who's now in my lab for a year, he's actually leaving end of this, it's nice to really understand that context and the value and what's happening. So it's not just about mining that data, it's understanding that data and making sense of it in that context. So I think there is value to having kind of building these bridges because I grew up in India, but I grew up having English as a language that I was very comfortable with. But being able to bring these information that exists in different languages and different cultures together, I think is really.
Did you find much in India?
Not yet. I mean, there is data that exists, but I don't have any specific collaborators right now pulling. It has to be the right person to do the right thing. So,
because I'd be curious to know where people are doing research. My impression is that there's a lot that goes on in China, probably less in India. And I think that my impression is that people in Russia who are trying to do research probably don't have an easy time of it, because I think the government is not enthusiastic about saving the world from climate change. And I don't know how much that affects their research capacity. Is that your impression, that it has deleterious effects on the quality of research they're able to do?
Absolutely. I mean, it's amazing to see what's happening in China with the amount of research that goes on there and funding. And it depends on that as to how much is being done or not.
Russia is the question. Do you get?
I do not know enough about Russia to be able to say anything in the space. My knowledge of Russia goes back to some of the older data sets and papers where I've seen amazing things come out of Russia, but I wouldn't be able to say anything about current data sets.
Well, of course, now it'd be difficult to interact with them because of the war, but my impression that was already there was a wet blanket over research on climate change in Russia, and I don't know enough to. I've not been able to contact a lot of people that I'd like to interview. Let's put it that way. Yeah. Well, we're getting close to the end. This has been extremely informative, very, very interesting. Where are you going with your research next? What are some of the issues you'd like to unpack with your next study?
So what I'm really excited about is in the next phase of the research, kind of thinking about these solutions in our new project called Solutionscapes and other grants. So thinking about developing these maps to say, like, which wetlands, where do you want to put the biodigesters, how many, what are the costs and benefits, what are the trade-offs, and doing that at a large scale, both in the Lake Erie Basin, but also in the prairies. So we scale these things up and really keep working on all these ideas.
Well, I hope you'll keep me informed about what you're doing because it's so interesting and it's really to some extent connected to some of the other interviews that I do. I'm doing a lot about various proposals for helping solve global warming issues. So this is part of it, you're really right in the middle of things. Huh? So keep me posted, if you will, and let's have another go at this sometime, perhaps with some other colleagues who will think, no doubt, about questions that wouldn't have occurred to me, right? Okay,
Thank you so much for your
thank
time.
you so much. I've enjoyed every minute of it, and I hope to see you again on this